XOR, or known as exclusive OR, is a problem in neural network to predict output with the logic gates with two inputs. Usually, the XOR function will give false value if the input has true value, and the function gives true value if the input has the false value. This is the output of the question. Single-layer perceptron is composed of a network of units which is a feed-forward network where it is a process of generating an output. It is the weight that determines the classification line. If all data points on one side of a classification line are assigned the class of 0, all other are classified as 1. Disadvantage of this question is that it is only able to separate the data points in a single line because there is no linear separability of the inputs of the XOR. This can be clearly seen in the plotted graph shown. There is no way to separate the 1 and the 0 prediction with a single classification line. Multi-layer perceptron is weight for each combination of input and hidden unit. The product of the input layer values and their respective weight are parsed. Each non-biased hidden unit invokes an activation function, usually the classic sigmoid function to squash the sum of the input values down to a value that falls between 0 and 1, usually a value very close to either 0 or 1. The output of each hidden layer unit, including the bias unit, are then multiplied by another set of respective weight and parsed to an output unit. The output unit also parses the sum of its input value through an activation function again. The sigmoid function is appropriate to return an output value falling between 0 and 1. This is the predicted output. This is more complex than the classic perceptron network, but it is capable of achieving the non-linear separation. So, the right set of weight values, it can provide the necessary separation to the accurately classify XOR inputs. Regularization of the learning algorithm has been done to avoid the overfitting which is imposed by some constraints over the parameter space, which will reduce the variance and increase the bias. Basically, there are many ways to avoid the overfitting. In this system, to avoid the overfitting, soft weight sharing, drop output, batch normalization, and early stopping algorithm has been used. Soft weight sharing will reduce the parameter space artificially by imposing explicit constraints, whereas the dropout will randomly kill some of the neurons during the optimization and predict the full network. Next, the batch normalization will re-normalize a layer inside batch so that the network does not overfit on this particular batch, and the early stopping algorithm will stop the gradient descent procedure when error on validation set increase. Is noise pattern for the input pattern. If there is noise in the system, the data has to be trained. This graph is the training error versus iteration graph, where the data has been trained to get the error of the system. Where it can be seen in the graph, the error reduces to 0 when it starts the iteration epoch at 8000. So, the decision boundary is set when the system has noise. The blue dots indicate values to be 0 and the green dots indicate the values to be 1. Looking into this graph, it shows that the red dots are actually green dots that has entered the blue dot zones. The two red dots nearly to 0.7, 1.5 and one red dot nearly to 1.25, 0.75 is actually the green dot that has entered the blue zone dot, whereas the red dot which is nearly to 1.75, 1.0 is actually blue dot entered in green dot zones. These red dots are actually values that has been predicted wrongly. This shows that the learning algorithm has managed the noisy data.